Welcome to your personalized deep dive into the power industry.
Right.
We've got a stack of articles and expert interviews from leading industry magazine ready to go.
Sounds good.
This deep dive is all about getting you up to speed on the innovations and honestly the massive challenges transforming how electricity gets from power plants all the way to your phone charger.
Mm-hmm.
It's way bigger than just keeping the lights on, would you say?
Absolutely. This transformation touches everything from the fight against climate change to national security, even what kind of car you might be driving in a few years.
Speaking of cars, one of the articles lays out how the demand for power is absolutely skyrocketing globally.
Oh, yeah.
They call it hockey stick growth.
Mm.
And with the rise of electric vehicles, I can see why.
It's not just EVs driving that surge. It's a perfect storm of factors.
Okay.
Think population growth, massive infrastructure projects like new railways and data centers popping up everywhere.
And those data centers are real energy hogs. I hadn't even thought about that.
Right. And on top of that, our aging power grids are struggling to keep up all while we're trying to shift towards more renewable energy sources.
Yeah.
It's putting immense pressure on the entire power industry.
Okay, so we're talking big numbers here, right?
Huge.
What kind of scale are we talking about?
The magazine forecasts a whopping 4 terawatts of new generation capacity added globally in the next 3 years alone. To put that into perspective, that's enough to power every home in the United States for an entire year.
Wow, that's mind-boggling.
Yeah.
But with demand increasing that rapidly, can the industry actually keep up?
That's the million-dollar question.
Yeah.
And that's where things get interesting because the magazine highlighted a really surprising bottleneck.
Okay.
Transformers.
Transformers. Those giant metal boxes you see at power stations and along power lines.
Exactly. And they're absolutely essential for a functioning grid. They regulate the voltage of electricity as it travels from power plants to your home, making sure it arrives at the right voltage for your appliances to work safely.
Okay, that makes sense.
Wow.
So what's the problem with transformers? Are we running out of them?
That's what's so surprising. The global production capacity for transformers actually exceeds the demand. Yet lead times for new transformers are stretching out to a staggering 3 to 5 years.
Wait, so we can make enough transformers, but it still takes years to get one? How does that even make sense?
It's a combination of factors. The magazine's research points to regional supply-demand imbalances, meaning that transformers might be readily available in one part of the world but desperately needed in another.
And I'm guessing getting those massive transformers shipped across the world isn't exactly easy.
Exactly. You've also got to factor in logistical hurdles, vendor approvals, and other delays that can pop up. Then you have skilled labor shortages in certain regions and even constraints on raw materials needed to manufacture transformers. All of this adds up to major delays.
So what does this mean for everyday people? Will our lights start flickering?
It's not quite that dire, but these delays have serious consequences. They can slow down critical infrastructure projects and potentially even derail our ambitious goals for electrifying transportation and transitioning to clean energy.
It sounds like a real domino effect.
Yeah.
Everything is so interconnected.
It really highlights how complex our modern power systems are. And this brings us to another key piece of the puzzle, renewable energy and the challenges that come with it. The articles were buzzing about the incredible progress we've made in solar and wind power, especially when it comes to cost reductions.
That's encouraging. But I know renewables aren't without their drawbacks.
Right. The biggest challenge is that they're intermittent. The sun doesn't always shine and the wind doesn't always blow, so we need ways to store that energy for when we need it.
And that's where energy storage solutions come in, right? I've been hearing a lot about lithium-ion batteries.
Exactly. The magazine dedicated a lot of space to lithium-ion batteries, which are becoming crucial for integrating renewables into the grid. But even scaling up battery production presents its own challenges. One expert, the CEO of Pennsylvania Transformer, highlighted that even with government support, there's a serious shortage of skilled labor needed to build these complex systems. It's not something you can learn overnight.
So even if we have the technology, we need the people to actually build it and maintain it. That makes sense?
Precisely. And it's not just about batteries. The magazine also touched on emerging technologies like perovskite solar cells, which are even more efficient than traditional solar panels, and massive offshore wind farms.
It seems like there's a lot of innovation happening in the renewable energy sector.
Absolutely. But it also means that the power industry needs to become more agile and adaptable to embrace these new technologies as they develop and mature. It's a really dynamic time for the industry.
And with all these new technologies and the increasing demand for electricity, how do we manage it all? How does the grid keep up?
That's where smart grids come into play. The magazine did a great job explaining how smart grids are using digital technology to manage the increasingly complex energy landscape. They act like the nervous system of a modern power system, constantly monitoring and adjusting to changes in supply and demand.
That sounds pretty high-tech. Can you give me an example of how that works in practice?
Imagine your neighborhood has a lot of rooftop solar panels. On a sunny day, those panels might generate more electricity than the neighborhood needs at that moment. A smart grid can detect that surplus and automatically route it to other parts of the grid where it's needed, preventing wasted energy and potentially lowering your electricity bill.
So smart grids are like the traffic controllers of the electricity world, making sure everything flows smoothly.
That's a great analogy. And smart grids are also essential for integrating what we call distributed energy resources, or DERs, into the larger grid.
DERs. I'm not familiar with that term.
DERs are smaller scale power sources like rooftop solar panels and home energy storage systems. They're becoming more and more common as people look for ways to generate their own clean energy and become more energy independent.
So a smart grid can manage all these different sources of electricity, from large power plants to individual homes with solar panels, making sure everything works together seamlessly.
Exactly. It's a complex balancing act, but smart grids are making it possible. And that brings us to another game changer, digitalization.
Digitalization. I guess that means more computers and sensors in the power grid?
It's more than just that. The articles were buzzing about how companies are using artificial intelligence and machine learning for something called predictive maintenance.
Predictive maintenance, so they can anticipate problems before they even happen.
Precisely. Imagine being able to predict when a transformer might fail based on its operating data and environmental conditions. That's huge for preventing costly downtime and ensuring the reliability of the grid.
That's incredible. It sounds like science fiction coming to life.
It's really revolutionizing the way the industry operates. And it's not just AI. They're also using real-time monitoring with internet-connected sensors to keep a close eye on everything from transformer temperatures to voltage levels across the entire grid.
Wow. It's like having a doctor constantly monitoring the vital signs of the entire power grid, making sure everything is healthy.
That's a great way to put it. And some experts are even exploring how blockchain technology, the same technology behind cryptocurrencies, could be used to create secure and transparent energy trading platforms.
Blockchain. Okay, that one's a bit over my head, but it sounds like they're really bringing the power industry into the 21st century technologically.
Absolutely. And it's not just about cool technology. It's about making the grid smarter, more efficient, more resilient, and ultimately more reliable for everyone.
Now, before we get too lost in the digital world, let's go back to those transformers we talked about earlier. I know we touched on the supply chain issues, but the deep dive actually went even deeper, focusing on a crucial transformer component.
You mean bushings? Those might seem like small details, but they play a vital role.
Okay, bushings. I'm not sure I've ever even heard those. What are they and why are they so important?
Bushings are the unsung heroes that connect transformers to the power lines. They act as a critical interface between the high voltage equipment inside the transformer and the surrounding environment, making sure the electricity flows safely and reliably.
So they're like the gateway between the high-powered electricity in the transformer and the outside world.
Exactly. And if a bushing fails, it can have serious consequences for the entire grid. The magazine highlighted a shift from traditional porcelain insulators to more resilient and adaptable silicone rubber for bushings.
I see why this switch to silicone rubber.
Porcelain, while a good insulator, can be brittle and prone to damage from weather impacts or even just age. Silicone rubber, on the other hand, is much more flexible and can withstand extreme temperatures and harsh weather conditions. It's a much more resilient material.
That makes sense. So they're using tougher materials to build these bushings to make the grid more reliable.
Exactly. And they're also exploring different technologies for bushings like oil-impregnated paper, OIP, resin-impregnated paper, RIP, and resin-impregnated synthetic, RIS. Each technology has its own advantages and disadvantages impacting safety, reliability, and environmental considerations.
Wow, it sounds like a lot of thought and engineering goes into these bushings.
It really does. They might seem like small details, but they can make a huge difference in the overall performance and reliability of the grid.
And speaking of reliability, the magazine included some pretty eye-opening insights from the Transformer Manufacturers Association of America, or TMAA. They had some strong opinions about the state of the industry.
The TMAA is a key voice for transformer manufacturers in the U.S. What did they have to say?
One of their leaders, the executive director, actually talked about how the industry is often stuck in a reactive mode, always playing catch-up to market pressures instead of being proactive.
That's an interesting observation. What kind of impact does that have on the industry?
He argues that this reactive approach is making it harder to overcome challenges and build a more resilient and sustainable power grid. He stressed the need for stronger collaboration between manufacturers, utilities, research institutions, basically everyone involved in the power sector.
So he's calling for a more unified approach to problem solving.
Exactly. He believes that the industry needs to speak with one voice, advocating for policies that support domestic manufacturing and a robust supply chain, which would ultimately benefit everyone. It would mean a smoother transition to a modernized grid and more reliable power for all of us.
That makes sense. Working together to address these challenges seems crucial, especially with the scale of the transformation happening in the power industry.
And it all boils down to this: knowing how vital transformers are and how long it takes to get new ones. What does this mean for our ability to achieve those ambitious clean energy goals?
That's the key question we need to grapple with. And luckily, the magazine didn't shy away from tackling those tough questions. They brought together a panel of experts to discuss these very challenges.
Okay, let's hear what this panel of experts had to say about the future of the power industry.
This panel really brought the complexity of this transformation to life. It highlighted how it's not just about technology, it's about policies, workforce development, even global cooperation.
It sounds like a massive undertaking. Do they offer any specific solutions?
They did. One panelist, a senior technical advisor for Camlin Energy, stressed the importance of risk management, particularly when it comes to transformers. He argued that it all starts with getting the specifications right at the very beginning of a project. If you make a mistake there, it can have a ripple effect and lead to problems down the line.
That makes sense. It's like building a house on a shaky foundation. No matter how beautiful it looks on the outside, it's going to have problems eventually.
Exactly. And one of the articles dug into a surprising fact about transformer failures. Apparently, a whopping 26% of them are due to a component called an on-load tap changer, or OLTC for short.
OLTC? That sounds pretty technical. What exactly is an OLTC?
Think of an OLTC like a dimmer switch for a transformer. It's responsible for regulating the voltage levels, especially when the demand for electricity fluctuates throughout the day. Without OLTCs, your lights might flicker or your appliances might not work properly.
So they're constantly adjusting the flow of electricity to keep everything running smoothly.
Precisely. But as one expert pointed out, OLTCs are complex pieces of equipment with a lot of moving parts, making them more susceptible to wear and tear.
So they're kind of like the Achilles heel of the transformer.
In a way, yes. That's why monitoring their condition is absolutely crucial. The magazine explored various monitoring techniques, including something called dissolved gas analysis, or DGA.
Dissolved gas analysis. How does that work?
It involves analyzing the gases that are dissolved in the transformer oil. Different gases can indicate different types of problems, kind of like a blood test can reveal health issues in a human. This allows technicians to identify potential issues early on before they turn into major failures.
So they're using data to get a glimpse into the inner workings of the transformer and catch problems before they cause a power outage.
Exactly. And they discussed other monitoring methods too, like tracking the energy consumption of the OLTC motor and looking for temperature differences that could indicate a problem.
It sounds like they're really using every tool in the toolbox to keep these transformers humming along.
They have to. And it highlights a larger trend in the power industry, a move towards data-driven decision-making. We're shifting away from reacting to problems after they occur to a more proactive approach, using data and analytics to predict and prevent those problems in the first place.
That sounds like a much smarter way to manage such a complex system.
Absolutely. And speaking of smart, the magazine highlighted a cool example of digital innovation, a new platform called Evolution, which is being developed by MR, a leading supplier of OLTCs, in collaboration with a company called Northern Transformer.
What's so special about Evolution?
It's built on MR's existing ETOS platform, which is designed to be super flexible and interoperable, meaning it can integrate data from all sorts of different systems. The CEO of Northern Transformer was really excited about how Evolution will give their utility clients real-time insights into their transformer's health.
So instead of waiting for something to break, they can see potential problems developing and address them proactively.
Exactly. It's about giving utilities the information they need to make smarter decisions about their assets, optimizing maintenance schedules, and ultimately ensuring a more reliable power supply for everyone.
That's amazing. It's like having a crystal ball for your transformer. You can see into the future and avoid those nasty surprises.
It's a powerful tool for sure, and it's just one example of how companies are leveraging digitalization to make the grid more reliable and efficient.
Now, we've talked a lot about the technology, but the magazine also delved into another important aspect, sustainability. What do they have to say about that?
They highlighted a company called Yosh High Voltage, a leading manufacturer of transformer bushings who are working on developing bushings that are not only more resilient and adaptable, but also environmentally friendly. It's a key trend in the industry, moving toward materials and technologies that have a lower impact on the planet.
That's great to hear. What are some examples of how they're making bushings more sustainable?
They're focusing on using materials that are recyclable and reducing waste throughout their manufacturing processes. They also talked about adapting their bushing designs to meet the specific requirements of different global markets, taking into account different grid standards, climate conditions, and safety regulations.
So they're not just thinking about the environment, but also making sure their products are tailored to the specific needs of different regions around the world.
Exactly. It's a holistic approach to sustainability. But sustainability isn't just about materials and manufacturing processes. It's also about the people working in the industry.
That's right. The human element is always a crucial part of the equation.
And that's where the magazine got really interesting. They featured a thought-provoking piece by an industry veteran, Brian Sparling, who raised concerns about a growing knowledge gap in the power industry.
A knowledge gap. What does he mean by that?
He's worried that as the older generation of engineers and technicians retires, there won't be enough skilled workers to replace them. These are highly specialized jobs that require years of experience and hands-on training.
So we might have the technology, but we might not have the people with the skills to actually build and maintain it.
That's his concern. He emphasized the need for utilities to invest in apprenticeship programs and encourage young people to pursue careers in the power sector.
That makes sense. But how do we attract more young people to the power industry? It doesn't exactly have the most glamorous image.
He had some great advice for young professionals entering the field. He encouraged them to never stop learning, ask lots of questions, and actively participate in industry organizations like IE and Siguri to build their networks and knowledge.
So it's about promoting a culture of continuous learning and mentorship within the industry.
Exactly. And it's about changing the perception of the power industry. It's not just about keeping the lights on anymore. It's about building a more sustainable future, developing cutting-edge technologies, and solving complex challenges that impact our lives every day.
I like that. It's about framing the power industry as an exciting and impactful career path, not just a technical job.
Exactly. And speaking of impactful, one of the experts from the HJ family of companies had a really interesting point about a seemingly insignificant component, gaskets.
Gaskets? Like the rubber seals you find in a car engine?
Similar concept, but in this case we're talking about gaskets that are used in transformer bushings. They might seem small, but they play a critical role in preventing leaks and ensuring the reliability of the bushing.
So they're like the tiny but mighty heroes of the power grid.
Exactly. And this expert emphasized how choosing the right gasket material is essential. You have to consider factors like extreme temperatures, chemical compatibility, even exposure to things like UV radiation and ozone, all of which can degrade the gasket over time.
It sounds like a lot of thought goes into choosing the right gasket for the job.
It does. He even mentioned how storing transformers in extremely cold temperatures before they're put into service can actually damage the gaskets and shorten their lifespan.
Wow, I never would have thought of that.
It just highlights how even seemingly minor details can have a big impact on the performance and longevity of these critical pieces of equipment.
It's all about attention to detail and understanding the interconnectedness of the entire system.
Precisely. And speaking of interconnectedness, the magazine did a great job of showcasing the human side of this industry transformation.
That's important.
Yeah.
It's easy to get lost in the technology and forget about the people behind it all.
Exactly. They profiled an inspiring woman named Florencia Rodriguez Lamas, who started as an intern in Argentina and is now a global leader in diversity and inclusion at Siemens Energy.
That's an incredible journey.
Right.
What were some of the key takeaways from her story?
She emphasized the need for more women in leadership positions within the power industry, not just in title, but in having real executive power to drive meaningful change. She also talked about the importance of supporting and elevating the voices of women through initiatives like the Women in Energy Network.
That's so important. Diversity brings new perspectives and ideas to the table, which is essential for solving complex challenges.
Absolutely. And it's not just about gender diversity, it's about creating a more inclusive and equitable industry for everyone, regardless of background or identity.
Now, in addition to Florencia's story, did the magazine highlight any other individuals who are shaping the future of the power industry?
They did. They had a fantastic interview with Randy Williams, a true veteran in the world of bushings.
Oh, wow, bushing expert. That's pretty niche.
He's a wealth of knowledge. He's witnessed the evolution of bushing technology firsthand, from those traditional porcelain insulators to the modern silicone rubber bushings we talked about earlier.
What were some of the key insights he shared about the industry?
He really emphasized the importance of understanding the nuances of different bushing technologies. He said that each one has its own strengths and weaknesses, and choosing the right one for a specific application is crucial. It's about being a problem solver, not just a part supplier.
So it's not a one-size-fits-all approach when it comes to bushings.
Not at all. He also stressed the importance of relationships in this industry. He said, and I'm quoting here, "It's all about relationships. It's about knowing the pulse of the industry. And if you don't have your finger on it, how it's changing and moving, not just the technology, but the people and what they need, the new requirements, if you're not on top of it, you're not on your game."
That's a powerful statement.
Yeah.
It sounds like he's advocating for a more collaborative and human-centered approach to doing business in the power industry.
Exactly. It's not just about transactions. It's about building trust and understanding the needs of your customers.
And did he have any advice for young engineers starting out in the field?
He encouraged them to focus not just on the technical aspects, but also on developing their communication and people skills. He said, "Mr. Harold Moore told me I was the best salesman he'd ever met who never sold anything because I only tried to educate people to make the right decision."
That's a great way to approach it. It's about being a trusted advisor, not just a salesperson.
Exactly. And that brings us back to the Transformer Manufacturers Association of America, the TMAA. The magazine had a special section dedicated to insights from their leadership team.
I'm curious to hear what they had to say. What were some of the key themes that emerged from their interviews?
They were very vocal about advocating for policies that support domestic manufacturing workforce development and a level playing field when it comes to international trade. They also emphasized the importance of attracting young people to the industry. One of their leaders, the chairwoman of TMAA, actually said, "We must have a better program to incentivize people to go to technical schools to learn the skills we need in the factory to build transformers."
It sounds like they're really concerned about the future of the workforce.
They are, and they're not just talking about it. They're actively working on solutions. But one of the most pressing issues they're facing right now is a shortage of something called grain-oriented electrical steel, or GOES for short.
GOES. What is that and why is it so important?
GOES is a specialized type of steel that's used in transformer cores. It's essential for making transformers energy efficient.
So without GOES, transformers wouldn't work as well.
They wouldn't be as efficient, which means they'd waste more energy. And the problem is that there's only one domestic supplier of GOES in the U.S., and they just can't produce enough to meet the demand.
So transformer manufacturers are stuck waiting for this crucial material.
Exactly. And to make matters worse, the limited domestic supply doesn't even meet the specifications required for some types of transformers, so they're forced to rely on imports, which are subject to tariffs, driving up costs and creating further delays.
It sounds like a real catch-22 situation.
Yeah.
What are they doing to address this GOES shortage?
The TMAA is working with policymakers to try and increase domestic production of GOES. They're also pushing for policies that streamline the import process and ensure a level playing field for manufacturers who are competing with foreign suppliers.
It sounds like they're really fighting for the interests of their members.
They are. And it's not just about protecting their own industry. It's about ensuring that the U.S. has a reliable and sustainable supply of transformers to meet the growing demand for electricity.
So it's a matter of national security, even.
In a way, yes. A reliable power grid is essential for our economy and our way of life.
Now, the magazine also featured a fascinating power panel discussion, and this one was all about bushings.
Yes, the bushing experts are back. What did they have to say this time?
This panel really drove home the point that the power system is incredibly interconnected. They highlighted how a single component failure, like a bushing failure, can have a cascading effect and potentially lead to widespread outages.
That's a sobering thought. It's a reminder that even small components can have a big impact on the overall reliability of the grid.
It's exactly. One panelist, the senior technical advisor for Camlin Energy, gave a pretty stark example. He said, and I'm quoting here, "Sometimes to replace a bushing, you have to replace the GIS connection. And to do that, you must change the layout of the substation. So it's often better to change the entire transformer if it's old enough. Until you do that, you just pray that the bushing doesn't explode."
Wow, that's quite a visual. It really emphasizes the importance of investing in the grid and keeping equipment up to date.
Absolutely. And the panel also talked about how extreme weather events are putting more stress on the grid. We're seeing more frequent and severe storms, wildfires, heat waves, all of which can damage power equipment.
That's definitely a growing concern, especially with climate change. How is the industry responding to these challenges?
One panelist mentioned that some utilities are shifting from pole-top transformers to pad-mounted transformers, which are more resilient to weather events.
That makes sense.
Yeah.
But I imagine that just creates more demand for transformers, which, as we've discussed, are already in short supply.
Exactly. It's a complex equation with many variables. But despite all these challenges, the panel also highlighted some exciting technological advancements that are shaping the future of bushings.
Oh, good. I was hoping there would be some good news in all of this.
One of the experts of VP of R&D actually talked about how the industry is pushing the limits of existing standards to meet the demands of higher voltage applications. As we move towards a more electrified future with more electric vehicles and renewable energy sources, we need higher voltage levels to transmit electricity efficiently.
That makes sense. But higher voltages also mean more stress on the equipment, right?
Exactly. So they're constantly having to innovate and develop new materials and technologies to handle those higher voltages safely and reliably.
It sounds like a never-ending challenge. What are some examples of those innovations?
One expert, the co-founder of Crosslink Technology, mentioned that they're developing new epoxy formulations for bushings that have improved surface energy and hydrophobicity.
Hydrophobicity. What's that?
It basically means water repellency. It's crucial for preventing contamination and maintaining the integrity of bushings, especially in harsh environments.
So they're making bushings that can repel water and dirt.
Exactly. It's all about making them more resilient and extending their lifespan.
And did this panel talk about the importance of collaboration like the previous experts we discussed?
Absolutely. One of the key themes that emerged was the need for closer partnerships between bushing manufacturers and their customers, both the OEMs, original equipment manufacturers, who build transformers, and the utility companies who operate them.
That sounds like a smart approach. By working together, they can share knowledge and develop better solutions.
Exactly. The co-founder of Crosslink Technology described their approach saying, "Years ago, we were given a drawing by our customer. Make it exactly like that. But now it's much more collaborative. We're working with the engineer to design what they need, how they need it, and when they need it."
It sounds like they're moving away from a transactional relationship to a more collaborative partnership.
Exactly. And the VP of R&D for the HJ family of companies echoed that sentiment, emphasizing that they love working with customers who bring them challenges to solve. He described their collaborative process, saying, "We work alongside them, passing ideas back and forth. We do 3D modeling, we do simulations, electrical, mechanical, we do flow simulations for our epoxy molding and casting, and then make tooling in-house, source all the components. And we have a high-voltage test laboratory."
Wow, they have the whole package. It sounds like they're really invested in helping their customers succeed.
They are, and they see those challenges as opportunities for innovation and growth. It's a win-win situation. Now, shifting gears a bit, the panel also spent quite a bit of time discussing potential failure modes for bushings and how to avoid them.
Failure modes. That sounds a bit ominous.
It's not as scary as it sounds. They're basically talking about the different ways that bushings can fail and what steps engineers can take to prevent those failures from happening.
That makes sense. What were some of the common failure modes they discussed?
Well, we already talked about gaskets and how important it is to choose the right material and install them properly. They also highlighted thermal cycling as a potential issue.
Thermal cycling. What's that?
It's basically the repeated heating and cooling of the bushing, which can happen in regions with extreme temperature swings. Over time, that constant expansion and contraction can cause cracking and material degradation, leading to bushing failure.
So it's like wearing down a piece of metal by bending it back and forth over and over again.
Exactly.
Yeah.
And one expert mentioned that they've even seen microcracks develop during installation due to improper handling or installation techniques.
So it's not just about the materials, it's also about the human factor.
Absolutely.
Yeah.
And that's why they emphasize the importance of proper training for installation crews and following the correct protocols.
Makes sense. What other failure modes did they discuss?
They talked about the potential for leakage to occur between the conductor and the epoxy insulation inside the bushing.
What happens if there's a leak?
It can allow contaminants to enter the bushing, which can degrade the insulation and lead to partial discharges, which are like tiny sparks that can eventually cause the bushing to fail completely.
That sounds pretty serious.
It is. And in a worst-case scenario, those contaminants could even enter the transformer itself, potentially damaging the entire unit.
So preventing leaks is a top priority. Did they offer any advice on how to avoid these failure modes?
They did. One of the experts, the VP of R&D for the HJ family of companies, had some great advice for young transformer design engineers. He stressed the importance of carefully considering the loading conditions for the bushing, including potential overloading scenarios.
Overloading, what does that mean?
It basically means pushing the bushing beyond its intended capacity. It can happen during periods of high demand or if there's a fault in the system. He explained, with many of the resin types, they're not built for overloading. Some are,
Yeah.
but you have to dig into it, see what material is used, what its capabilities are, and talk to the manufacturer.
So it's about knowing the limits of the materials and designing the system with enough safety margin to handle those unexpected situations.
Exactly. And he also emphasized that even if the insulation itself can handle an overload, the gaskets might not. They could get damaged even during a short-term overload.
It sounds like there's a lot to think about when designing these systems.
There is, and another expert, the co-founder of Crosslink Technology, had some great advice for young engineers. Learn from those who have been in the field for many years. He said, for a young engineer, I would strongly recommend that they talk to people that have been in the field for a number of years to get a feel for the theoretical and the practical.
It's that blend of theory and practical experience that makes for a truly skilled engineer.
Absolutely. He went on to say, if anything, I would tell a young engineer to really pay attention to people who've been around and listen to the practical experience.
That's great advice. There's no substitute for experience, especially in a field as complex as this one.
Now, in addition to design considerations, the panel also emphasized the importance of monitoring and diagnostics for bushings.
Makes sense. If you can catch a problem early on, you can prevent a bigger failure down the road.
Exactly. And the senior technical advisor for Camlin Energy stressed the importance of asking the right questions when designing a monitoring program. He said, you must ask the right questions at the beginning before starting to do the design. What Jeff was saying about overloading is very important. In the practical case, we do overload calculations for transformers. Sometimes you might not consider, for example, bushings and tap changer in your calculations because you are doing the calculations for the transformer. So you look around the windings, the maximum current in the windings, and so on. And you might forget that if you apply that current, you might be exceeding the maximum current of the bushings.
So it's about thinking about the entire system, not just individual components in isolation.
Right. And he also pointed out that monitoring bushings that are part of larger, more complex systems like gas-insulated switchgear or GIS for short can be more challenging.
Why is that?
Because those systems are often very integrated, making it harder to isolate and monitor individual components.
Ah, I see. So it requires a more sophisticated approach to monitoring.
Exactly. And that's why he stressed the importance of collaboration between the engineers who design the monitoring systems and the asset managers and subject matter experts at the utility who are responsible for maintaining the equipment.
It sounds like teamwork is a recurring theme in this industry.
It really is. Everyone needs to be on the same page to ensure the reliability and safety of the power grid.
Now, one of the biggest challenges facing the power industry today is the aging of the grid.
That's right. A lot of our power systems were built decades ago, and they weren't designed to handle the demands of our modern world.
So we're trying to plug 21st century technology into a 20th century grid.
In a way, yes.
Mm-hmm.
And the panel talked about how the increasing use of renewable energy sources is actually accelerating the aging of transformers.
Sounds counterintuitive. I thought renewable energy was supposed to be good for the grid.
It is, in the long run. But in the short term, it's creating some challenges.
Like what?
Well, renewable energy sources like solar and wind power tend to be more intermittent. The power output fluctuates depending on the weather conditions.
So it's not as steady and predictable as traditional power plants.
Exactly. And those fluctuations can create more transients and harmonics in the grid, which can put additional stress on transformers.
I see. So it's like driving your car in stop-and-go traffic all the time. It puts more wear and tear on the engine.
That's a great analogy.
Right.
And one of the panelists, the VP of R&D for the HJ family of companies, specifically mentioned reverse power flow as a potential problem.
Reverse power flow, what is that?
It's a phenomenon that can occur when solar panels are generating more electricity than is being consumed locally. Instead of flowing from the power plant to the homes, the electricity flows back towards the power plant.
So the grid is operating in reverse.
In a way, yes.
Mm-hmm.
And that can cause increased heating in transformers, which can shorten their lifespan.
So it's like pushing electricity through the transformer in the wrong direction?
You can think of it that way. And another expert, the co-founder of Crosslink Technology, pointed out that all of these factors are essentially running our equipment hotter than it was designed for.
That doesn't sound good. What can be done about it?
They stress the need for more robust transformer designs that can handle these higher temperatures and more fluctuations in power flow. They also emphasize the importance of better monitoring systems to detect problems early on.
It sounds like a multifaceted problem that requires a multifaceted solution.
Exactly. And ultimately, it highlights the need for grid modernization. We need to upgrade our aging infrastructure to make it more resilient and adaptable to these new challenges.
That makes sense. So despite all these challenges, did the panel offer any hope for the future?
They did. They were actually quite optimistic about the future of the power industry. They see all of these challenges as opportunities for innovation and growth.
That's good to hear. What are they most excited about?
They pointed to the growth of renewable energy, the adoption of smart grid technologies, and the increasing use of data analytics as key trends that are shaping the future of the industry.
Those are all positive developments. And what about the role of people in all of this?
They emphasize the importance of collaboration, knowledge sharing, and a willingness to embrace new approaches.
So it's about fostering a culture of innovation and continuous learning.
Exactly. And each of the panelists shared how their companies are contributing to this transformation.
I'm always curious to hear about real-world examples of innovation.
Well, the VP of R&D for the HJ family of companies talked about their commitment to continuous improvement. They're optimizing their epoxy molding processes and developing new materials to meet the demanding requirements of bushing applications.
So they're always striving to make their products better and more efficient.
They are. And the co-founder of Crosslink Technology emphasized their focus on customization and collaboration, working closely with their customers to develop tailor-made solutions that meet their specific needs.
It sounds like they're taking a very customer-centric approach.
They are. He said, everything we do, we try to be customizable to the customer. We do projects that other people don't want to do or think it takes too much time. Our philosophy is not to make our specific customer's company successful, but to actually make the engineer look successful.
That's a really interesting philosophy. They're focused on making their customers' lives easier and helping them achieve their goals.
Exactly. And the senior technical advisor for Camlin Energy highlighted their focus on building trusted partnerships with their customers.
I like that. It's about building relationships, not just selling products.
He said, our mission is really to establish a trusted partnership with customers. And that's why we moved from selling the sensors, like we did even 20 years ago, into now the software and the services, because we see this need to assist the customer. It's a mutual learning.
So they're not just providing technology, they're providing expertise and support as well.
Exactly. They see themselves as partners in their customer success. Now, in addition to the power panel, the magazine also included an article about the CIGR conference, which was held in Paris in 2024.
CIGRE, I've heard of that. Isn't it a big international conference for the power industry?
It is. They bring together experts from all over the world to discuss the latest advancements and challenges in the power sector. The article described the conference as a hub for networking, knowledge sharing, and relationship building.
That sounds like a valuable event. What were some of the key takeaways from the conference?
They interviewed several thought leaders who shared their perspectives on the trends shaping the industry. One expert, the CEO of Condis, summed up the current state of affairs perfectly when he said, "We are living in an unbelievable moment in our industry. Investments in electrical infrastructure are just massive."
It sounds like a time of great change and opportunity.
It is. And the experts at the conference emphasized the importance of standardization, better production planning, and more investment in research and development to meet the growing demand for transformers and other critical equipment.
It sounds like they're calling for a more coordinated and strategic approach to managing this industry transformation.
They are. One expert, a senior member of IE, had a great quote that really captured the spirit of the conference. He said, "Explore. The grid does not come to you. You need to go into the grid."
That's a great call to action.
It is. It's about being proactive, not reactive, and actively shaping the future of energy, rather than just waiting for it to happen.
It sounds like the power industry is facing some major challenges, but there's also a lot of excitement and optimism about the future.
Exactly. It's a complex and fascinating industry that's undergoing a profound transformation. And it's going to be interesting to see how it all unfolds in the coming years. It sounds like everyone agrees that we need to be more proactive in shaping the future of energy.
Yeah, definitely.
But what does that actually look like?
Wow.
What concrete steps can we take to address these challenges?
The magazine offered several practical suggestions. They emphasized the importance of accelerating standardization, especially for new technologies like digitalization and smart grids.
Standardization. Why is that so important?
Think of it like a universal language for the power grid. If everyone is using the same standards, it's much easier for different systems and technologies to communicate with each other. It can help streamline development, reduce costs, and accelerate the rollout of new solutions.
Ah, that makes sense. It's like having a common set of rules that everyone agrees on.
Exactly. And they also highlighted the need for better production planning, encouraging closer partnerships between manufacturers and their suppliers.
That makes sense, especially with those long lead times we talked about earlier.
Right.
If you're waiting years for a critical component, it throws a wrench into the whole production schedule.
Exactly. Closer collaboration and more transparency between manufacturers and suppliers can help mitigate those supply chain bottlenecks and ensure that projects stay on track.
And do they have any other suggestions for improving efficiency and reliability?
They talked about using monitoring and data analytics to not only improve reliability, but also reduce the knowledge requirements for certain tasks. By using technology to automate some of the more routine tasks, they can free up skilled workers to focus on more complex problem solving.
That's a clever approach.
Yeah.
It's about working smarter, not harder.
Exactly. But it's not just about the technology, it's also about creating a work environment that attracts and retains talent.
So making the power industry a more appealing place to work. How do they suggest doing that?
They highlighted the need to do a better job of showcasing the exciting career opportunities available in the power sector.
Yeah, for sure.
It's not just about keeping the lights on. It's about building a more sustainable future, developing cutting-edge technologies, and solving complex challenges that impact our lives every day.
It's about making a real difference in the world.
Exactly. And they also stressed the importance of investing in training and development programs to equip workers with the skills they need to succeed in this rapidly evolving industry.
It sounds like a multi-pronged approach is needed to address these workforce challenges.
It really is. And it all boils down to this: the power industry needs to adapt and evolve to keep pace with the changing world.
That's a great point. The magazine did a fantastic job of capturing this sense of transformation and highlighting the key innovations, challenges, and opportunities that lie ahead.
It's clear that the future of energy is electric, and it's going to be an exciting journey.
It definitely seems like we're on the cusp of a major shift in how we generate, distribute, and consume energy.
Absolutely. And with the right investments, policies, and most importantly, the right people, we can build a power grid that's not just reliable and efficient, but also sustainable and equitable.
So what does this all mean for our listeners? What can they do to stay informed and engaged in this energy transformation?
Well, first, I hope they feel a little bit smarter about the complex world of electricity.
For sure.
But more importantly, I hope they feel empowered to learn more and participate in the conversations shaping the future of energy.
Because at the end of the day, it's not just about keeping the lights on. It's about powering our lives, our communities, and our world forward.
And that's a mission worth getting charged up about.
Thanks for joining us on this deep dive into the power industry. We'll catch you next time for another electrifying exploration of the forces shaping our world.